Alright, this is going to be lesson 2.2, part 4. I'm going to let Mr. Martin go through the first chunk of this, and I'm going to throw in another example at the end for area of a circle. So let me get this one going for you guys.
One example that I thought was relevant that you might need help on for your assignment today. This one says, find the equation of the parabola through the point -4, -13, and tangent to the line y equals -8x plus 5 at the point 1, -3. So first we want to consider the graph. Okay, we have this point down here, -4, -13. We have this line here that goes through the point 1, -3. That's this point, and has a slope of -8. So I'm going to go up 8 and left 1 to get to this point here at 0, 5. And so if I have a parabola that's tangent to this point and hits it in just one place and goes through here, clearly we can see our view of the parabola is going to open downward and be something like this shape here that I'm marking off with my mouse. So right from that we know something about A. We'll come back to that later, but you can kind of tell me something already about what we know about this coefficient. So if it says find the equation of the parabola, I should backtrack. That means we need to find A, B, and C and then plug them into the standard form for the equation of a parabola. We want to get y equals ax squared plus bx plus c. So our goal is to find A, B, and C. So from this information here, a couple things need to be pulled. First of all, the fact that we have 2 points on the parabola means that we can plug this x-coordinate and this y-coordinate, or same thing here, in for x and y and make a true statement. So we're going to end up creating a system of equations, which you can kind of see below. But the part that has more to do with calculus is this. If we have something that's tangent to a certain line at a certain point, from this we should pull the information that tells us that right here, the derivative of the curve at that at that x coordinate of 1 is equal to the slope of the tangent line. So in other words, y prime of 1, what does that equal? Okay. What does that equal? Equals 8. Excuse me, -8. Okay. This tells me that the slope of this tangent line will be equal to the derivative at that particular point of tangency. Okay. Why is that true? Because y equals -8x plus 5 is tangent at that point. So now, let's see what else we've got here. We said we want to now use the 2 points that are on the curve and come up with equations. If I take -4, -13, plug it in for x and y, and then same thing with this one here, then I will get the following 2 equations. For the point at 1, -3, I get this equation. For the point at -4, -13, I get this equation. And when you clean it up, you get 2 equations in A, B, and C that we can start to get a system of equations. Obviously, if we have 3 unknowns, we want 3 equations, but we'll pull in the derivative part later on. So from here, if we subtract these 2 expressions here to make the C's cancel out, then I get this equation here. All I did was the top minus the bottom to get this equation. A minus 16a gives me this. B minus -4b gives me this. So this is an equation in A and B only. So now let's go back to the notion that from the derivative to get our other equation in A and B. If y prime of 1 equals -8, can we do something with this generic form of the equation for a parabola and get the derivative of that in terms of A or B or C or all 3? Well, yeah, if we take the derivative of this equation with respect to x, we will get y prime equals, and then do the power rule on this term, the 2 it comes in front, so it's 2a times x, and then what's the next term going to be? Plus, treat b like a constant, so it's just going to be plus b, and c is a constant, so its derivative is 0. So we know that y prime at any point on that parabola is going to be 2a times x coordinate plus b. And so if we have an equation that y prime of 1 is -8 because of this fact here, then we can plug in a 1 here for x and a -8 here for y prime, that is the derivative at the when x is 1, and get this following equation. So -8 equals 2a times 1 plus b. That's the whole trick of this problem that is probably new to you. This is the part that comes from calculus. So now we have an equation here in blue that is also another equation in A and B. And now let's take a look at this system of two equations and two unknowns. You can solve it however you want. You don't have to do it the exact same as I do, but I noticed that if I multiply the bottom equation by -5 and rewrite the whole system, then the denominator the top equation is the same, but the denominator will be the following. And so that gets my b's to cancel out, and so when I add straight down, I get 50 equals -25a, or a is -2, which coincides with what we started with when we consider our graph. We should have known that a is going to be negative because that by the picture alone, we know it has to open downward. Okay, so now we back substitute to solve for b and c. Pretty standard stuff. You can plug into this in anywhere. I plugged this value of -2 into this equation right here, since that's probably the simplest one in terms of a and b. So if I have 8 times -8 equals 2a plus b from this equation, plug in the -2 for a and substitute, and you get, and solve for b, and you get b equals -4. And now we plug in -2 and -4 anywhere and solve for c. I think I probably did it in this top one here, since that's the simplest. So we know what that looks like, and we solve and we get c equals 3. So you're not done until you have written it as an equation. The directions at the top said find the equation of the parabola. Well, we did all the hard part. Let's put it together. So this is going to be y equals -2x squared minus 4x plus 3. There's your a, your b, and your c. So that's that. The homework hint for today is for problem number 89, you're asked for the tangent. You're asked to work with the tangent line and its equation through the point 1, -9. And so the equation of any line through a given point can be given, if you have the slope here, can be given as y plus 9 equals the slope times x minus the x-coordinate, in this case 1. So if we do some substitutions here in terms of our notation for calculus, y is going to be the function here, f of x. The slope of that tangent line is going to be the derivative, so that we can replace this expression here with f prime of x. And now if we put the function in here and its derivative here, and then solve for x, we will get the point of tangency, and that should help save your assignment.
All right, so let me give you guys one more example here. Let me turn the page on this. And so just something we can do with any formula. We're just using area of a circle for this one, but we can find an instant rate of change involving a couple different variables on this one. So we're taking the area of a circle formula, pi r squared, looks like this. Obviously r is the radius, a is the area, and we know that the area is affected by whatever value we plug in for r. So this is our input, so that's like our x value, and this is our output, it's like our y value. So if we're going to write this as the rate of change of the area with respect to the radius, so think of this as your y and your x. So if we differentiate derivative of the area with respect to the radius, so we'd write that as dA over dr. It's just like writing it as dy over dx, where the difference in your y's over the difference in your x's. Remember, all of that is just coming from our slope formula, so that's why derivative is slope. So if we differentiate this guy, multiply the 2 to the front, we're going to get the derivative that looks like this, and now we could use it to find an instant rate of change for any radius that we want to use it for. So this one says, what's the instant rate of change when the radius is 8? So now I can just simply sub in the 8, and I got 16 pi as the rate of change at that point.